Welcome back to section 3, Rational Indices. In this video, we're going to have a look at a few examples of how we can simplify some rational indices. So, example 1, simplify each of the following, expressing your answers with positive indices. Part A. So have a look at this question here. We've got a to the power of a half times a to the power of a quarter, all divided by a, or the fourth root of a raised to the power of 3, and the square root of a raised to the power of 3. So to deal with this particular question, the way I'm going to attack it is, firstly, I'm going to get rid of the fraction altogether and express everything as a negative indice. And then I'm going to get rid of all of these bases and just express it as a single base by bringing or using the index laws to bring all the powers together. So jumping straight into it, we're going to go a to the half times a to the quarter, so nothing new there. But now I'm going to deal with the denominator. So that will become a to the negative 3/4, and then a to the negative 3/2. Now dealing with this, we'll go down the line. We have to make all of these powers a common denominator. So we need a to the power of 2/4 times a to the power of a single quarter times a to the negative 3/4 times a to the negative 6/4. Simplifying that, 2/4 plus 1/4, so it will become 2/4 plus 1/4 minus 3/4 minus 6/4. And then adding all of these together, we're going to get 2/4 plus 1/4 is 3/4. Take 3/4 is nothing, so we're left with a to the power of minus 6/4. Now we could call it a day and say that's our answer, but remember the question's asking us to express your answers with positive indices. And notice we've got a negative indice here, so we have to express it using our index laws. So we have to go 1 over, because it's a negative, a to the power of 6/4, and then we can go one better, and we can simplify this power and go 1 over a to the power of 3/2. And there would be our final solution right here. 1 over the square root of a raised to the power of 3. Now going across to b. Notice that we've got a mix of powers, negative fractional powers, and radicals. So this is a real mix right here. But nevertheless, it's nothing we can't handle. So I'll start it up here and we'll go, firstly, we'll get rid of all of these radicals. And then we'll take the steps that we did in part A, and firstly getting rid of the fraction altogether, and then bringing everything together. So we'll go 2 times a to the power of a half, then b to the power of negative 1/4, like so. Then we're going to get 2 to the power of a negative half times a to the power of a negative half as well. And then we've got b to the power of a half. Now going down, we're going to get rid of the fraction. So we'll have 2 to the a to the power of a half times b to the power of a negative quarter times a, or times 2 I should say, times 2 to the power of a negative half. But remember, it's not a negative anymore because we're not expressing it in the denominator. We're bringing it up, so it will become simply a half because the two negatives will cancel. And then we've got a, and same conditions as well. It was negative like that, but now it's going to be positive. And then the b, b to the b to the half is going to be b to the negative half because we're expressing it on the top line now. Okay, now let's collect like terms. So we've got 2 times 2 to the half. All right, and then we've got the a's, a to the half, a to the half, like so. And then we've got the b's, so b to the negative quarter and b to the negative half. Now, looking at this, we can write going back, we can clean it up a little and we'll say, notice that we've got 2 times 2 to the 2 to the half. To add this together, we can pretend that the first 2 has a power of 1. Now we didn't actually change it because that 1 is implied, but what it's going to do is it's going to make it clearer to see what exactly is going on here. So it will be 2 to the power of 1 plus a half. Then that's times by a to the half plus the other half. And then we've got the b to the negative quarter minus the half, like so. Cleaning that all up, we're going to get 2 to the 2 over 2 plus a half, a to the half plus a half, and then we're going to get b to the negative quarter minus 2 quarters. Adding these fractions all together, we're going to get 2 to the power of 3 over 2, a to the power of 1, and then finally b to the negative 3 over 4. Now writing this as a positive indice, we're going to get 2 to the power of 3 over 2, a, that 1 is implied, and then downstairs we're going to get b to the 3 quarters, like so. And this is what we find our answer to be. The square root of 2 raised to the power of 3 times a, all divided by the fourth root of b raised to the power of 3. Now let's go down and have a look at question C. Moving on to question C, notice that once again we've got an expression that is a mixture of fractional indices as well as negative fractional indices, and everything here has been raised to the power of a half, or we could say it's all been square rooted. So it might look a little bit intimidating to begin with, but so long as we follow the steps that we've done in the previous questions, we should be fine. So the way in which I'm going to tackle this one is I'm going to get rid of the brackets first. So we're going to bring this square root, or this half, into the expression. So that will be 4 raised to the power of a half, like so. Then x to the negative a half times the half. Then y to the negative third times the half, like so. Dividing that all through by 9 to the power of a half. Then x 1/3 times the half, and then y to the negative half times the half. Simplifying that out, we're going to get rid of the fraction altogether. So we can go 4 to the half, then x to the negative quarter, then y to the negative sixth, then it's going to be 9 to the power of a negative half, and then x to the power of a negative sixth, and then y to the power of a positive quarter. Positive because it was a negative when it was in the denominator, and now we're writing it all on a single line, so it becomes positive again. Simplifying that out, the square root of 4 is going to be 2. Then the x, the power of negative 4, then collecting like terms, it will be minus the 6, like so. and then we're going to get y to the -6 plus the quarter, and then we're going to get this 9 raised to the power of -half, which can be distilled down to 3 to the -1. So we simply take the square root of the 9 and put it as a 1/. Alright, perfect. Now bringing everything together, we're going to get 2 times 3 to the -1 times the x, and it's going to become x to the power of -1/4 minus -6. I believe that will equal the -1/2, and then it will be times y to the power of 1/12. And I've seemed to have made a little mistake with the x. It won't be to the power of a -1/12. It will be to the power of -5/12, like so. Now, expressing this as, or expressing it without the negative indices, in the denominator we're going to get 3 because of the -1, and then the x to the power of 5/12, and then in the numerator we're going to get 2y to the 1/12, like so. And this would be our answer, 2 to the power of, or 2 times y to the power of 1/12, all divided by 3x to the power of 5/12. So not really that complicated, just a few steps to do. Alright, next let's do question D. So notice in question D, rather than dealing with an expression that has variables in it, notice all of the features of this expression, or all of these factors, are numbers. There are no variables whatsoever. But look more closely at the numbers. We've got 8, 9, half, 3, and 2. All of these numbers are they can either be expressed as a base of 2 or a base of 3. So 8, for example, we can write that as 2 to the power of 3. And 9, we can write that as 3 to the power of 2, or 3 squared. And then have the third out here. And then the half, we can rewrite that as 2 to the -1, or to the power of a half. So there's our numerator, and our denominator is 3 to the -3rd times 2 to the quarter times 3. And if we want to be pedantic, we can say 3 to the power of 1. Now writing everything on a single line, we're going to get 2 to the 3 times 3 to the 2/3 times 2 to the -1/2 times 3 to the 3rd times 2 to the -1/4 times 3 to the -1. Collecting like terms, we're going to get 2 to the 3rd minus a half minus a quarter times 3 2/3 plus a third minus a 1. And then what we're going to find is 2 to the power of 3 minus half minus a quarter. That's going to be 2 to the power of 2.75. Or we could rewrite it as 2 to the power of 9/4 times 3 to the power of 0. And that will simply come out as 2 to the power of 9/4. So not so difficult after all. So what I hope you learnt from watching this video is that so long as we follow the basic rules involved in dealing with indices, we can be given any question that can look as obnoxious as it possibly can, and we'll still be able to deal with it. We just have to follow the rules in a systematic manner. In the next video, we'll have a look at question 2, expand and simplify.